Hi everybody. As promised, I am back with another problem that we might want to take a look at if we're struggling a little bit with the difference between and or probability problems. So let's take a look at our problem. Sara Lee has a bag with 4 danishes in it: an apple danish, a blueberry danish, a cheese danish, and a raspberry danish. Sara Lee randomly grabs one danish from the bag, looks at it, replaces it, and then grabs another danish. Make an array, tree diagram, or organized list of the possible outcomes. All right, ladies and gents, at this time, I'm going to ask you to pause the video, go ahead and make either an array, a tree diagram, or an organized list with all the possible outcomes. You can totally choose whichever one you feel best about. And when you're done, go ahead and resume the video. Okay, you guys, I could not decide which one I wanted to use. My two favorite methods are arrays or tree diagrams, and I couldn't decide. So I decided to let you guys in on my little experiment on how I'm going to decide. I'm going to actually make a spinner labeled array and tree diagram. I'm going to spin a paper clip on it, and then that's whatever it lands on, that's the representation I'm going to make with you guys. All right, tree diagram it is. All right, you guys, so for this problem, I decided to make the tree diagram, and I'm going to do that with you guys. Remember that a tree diagram starts with one point at the top, so I'm just going to put one point up here. And our first event is going to be listed across my paper. If you remember, I do recommend that you spread those choices out a little bit. So our first event is that Sara Lee randomly grabs one danish from the bag. So I'm just going to call that first grab. And the things that can happen when she reaches into the bag to pull out a danish is she could pull out an apple danish, or a blueberry, or a cheese danish, or a raspberry danish. So there are 4 options, which means I should have 4 branches that are connecting my options up to that starting point. Now, the second event, I'm just going to call that second grab. Okay, now if she chooses the apple, now remember, it did say she replaces it. So whatever she picks, she puts it back in the bag, which means that all 4 options are still going to be available in her second grab. So if she picks apple first, she could still choose apple again, or blueberry, or cheese, or raspberry. Okay, if she picks blueberry first, she could pick apple, blueberry, cheese, or raspberry. If she picks cheese first, she again could pick, I know you're shocked, apple, blueberry, cheese, or raspberry. And if she picks raspberry first, again, she could pick apple, blueberry, cheese, or raspberry. Okay, now I do recommend that you list your possible outcomes. Now I'm going to abbreviate. So she could choose apple, then apple, or apple, then blueberry, apple, then cheese, and apple, then raspberry. If she picks blueberry first, it could be blueberry, then apple, blueberry, then blueberry, blueberry, cheese, and then blueberry, raspberry could happen. If she picks cheese first, she could pick cheese, then apple, cheese, then blueberry, cheese, then cheese again, and last but not least, cheese, then raspberry. And if she picks raspberry first, it could be raspberry, then apple, raspberry, then blueberry, raspberry, then cheese, or raspberry with raspberry again. First question, how many possible outcomes are there? So 4, 8, 12, 16 possible outcomes altogether. What is the probability that Sara Lee will grab an apple or a cheese? Now, remember that when we see the word or, what that means is we have to satisfy the first condition or the second condition. Okay, so anything with an apple, I'm going to circle right now. This one's got an apple, 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 apple. Here's one with an apple. Here's one with an apple. And here's one with an apple. Okay, the other condition is or a cheese. So anything with a cheese, I'm going to circle. So I see a cheese here, 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 and here. Now remember with or, it has to satisfy one or the other. So probability that she will choose an apple or a cheese is going to be, I'm going to just count all of the circles because it only has to satisfy one or the other. So they don't have to be double circles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 that have an apple or a cheese out of 16 possible outcomes altogether. If I simplify this, I can divide both of these guys by 4, and my probability turns out to be 3/4. All right, we've got one more question that I'm going to throw at you guys, and that is, what is the probability that Sara Lee will grab a blueberry and a raspberry? Okay, so remember that for an and problem, we have to satisfy both of the conditions. So I'm going to circle anything with blueberry in this lovely light blue. So anything with blueberry. Here, I'm going to put a box around anything with blueberry. All right, I don't see any more blueberries. Okay, and then, and raspberry. Okay, so now I want to look at the blueberries I have and find out if any of the blueberries also have a raspberry with them. So this blueberry does not, and since it has to satisfy both, that one is out. No, I don't see a raspberry here or here, but hey, there's a blueberry and a raspberry. Nope, doesn't have both. This one does have both. So there are two options that have both a blueberry and a raspberry out of the 12, of the 16 possible outcomes altogether, which if I divide both of these guys by 2, I will get 1/8. All right, ladies and gentlemen, that is our extra problem in case you needed a little extra. I hope you guys have a wonderful day. Bye-bye.